So here we are again. We will kind of compute for this differential equation through power series method, but now the given is y prime is equal to xy. So this is also equal again to y prime minus xy is equal to 0. So we know that y is equal to summation of cn times x raised to m from 0 to infinity. Well, our y prime is equal to summation of n times cn times x raised to n minus 1 from 1 to infinity. So let's substitute summation of n times cn times x raised to n minus 1 from 1 to infinity minus summation minus x times the summation of cn times x raised to n from 0 to infinity is equal to 0. So again, this is equal to summation of n times cn times x raised to n minus 1 from 1 to infinity. So minus summation of x raised to n plus 1 times cn from 0 to infinity is equal to 0. So now what we are going to do is that we will change the value of n, because we must need to make this same for us to have some values that or variables to be factored. So let's do some changing here. So this will become summation of n plus 1 times c sub n plus 1 times x raised to n minus summation of c sub n minus 1 times x raised to n is equal to 0. So what we do here is that we deduct 1 from the value of n to this minus 1 and add 1 to this n and to this n. That's why we arrive to this summation notation. So now this will become c1 plus summation of n plus 1 times c sub n plus 1 times x raised to n minus summation of cn minus 1 times x raised to n from 1 to infinity is equal to 0. So now we have some values that can be factored out. So c1 plus, so here the summation notation can be factored out as well as the x raised to n. So now, so it's equal to 0. So let's find the recursion relation. So c sub 1 is equal to 0. C sub n plus 1 minus C sub n minus 1 is equal to 0. So therefore our relation is C sub n plus 1 and is equal to C sub n minus 1 over n plus 1. So here when n is equal to 1, our C2 is equal to CO over C2 over 2. When n is equal to 2, our C3 is equal to C1 over 3, where it's equal to 0. This is C. So when our n equals 3, our C4 is equal to C sub 2 over 4, which is equal to C sub O over 8. Well, when our n is equal to 4, C5 is equal to C3 over 5, which is equal to 0. So when our n is equal to 6, our c sub 7 is equal to c sub 5 over 7, which is equal to 0. Then when our n is equal to 7, c sub 8 is equal to c sub 6 over 8, is equal to c sub O over 38. When our n is equal to 8, our c sub 9 is equal to c sub 7 over 9, which is equal to 0. So all the add values here have a value wherein the negative wherein the even values will correspond to a 0 value. So now let's find out what can we do to the solution of this power series. So what we will gonna have is y is equal to c sub O plus c sub 1x plus c sub O times x squared over 2 plus c sub O times x to the 4th over 8 plus c sub O times x raised to 6 over 48 plus c sub O times x cubed over 384. So what I've searched that is that if this summation notation is summation of x raised to 2n over 2 raised to n factorial from n is equal to 0. So I searched it from Wolfram software, and that was generated formula. So as we notice here, the value is just like x squared over 2, x to the 4th over 8, and x to the 6 over 48, and so on. So we know that the power series transform no, I'm sorry for that. We know that the power series of e raised to x equivalent is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. So what can we notice is that if this x is x squared over 2, this will become 1 plus x squared over 2 plus x to the 4th over 8 plus x to the 6th over 48, which is also relevant to this, which is equal. So our final answer is y is equal to CO times e raised to x squared over 2.